So yeah, my name is Alvaro. I'm a developer advocate, whatever that means, for Pivotal RabbitMQ. I'm co-author of the book RabbitMQ in Action. I'm created some Rabbit simulator that I will show later. And if you, I guess people in this conference like Erlang, so in that series of blog posts, I've been documenting how RabbitMQ works internally. My idea is to get going that and get to a book at some point. I'm kind of masochist. I already suffered one book, and I want to suffer a second one. Yeah, and my role at RabbitMQ is, you can look at me as the marketing guy, but I'm also doing code, creating plugins, fixing bugs, writing documentation, writing clients, getting the blame for all the clients that don't work and stuff like that. So there's a lot of things behind this title. That's the book that she mentioned before. You can go and buy it. I guess it soon will need a second edition because it was written. We started writing this book when RabbitMQ 1.7 was out, and now today it was 3.3 point something out. So yeah, it's getting a bit outdated. So the idea of this talk is to be like an exploration kind of thing of what can be done with RabbitMQ, not necessarily how to actually do it, because I think everybody in this room can go and knows the website. Let me Google that for you. So you can go to the documentation, see how to actually get the code to do something. Yeah. So the idea is to have an intro to RabbitMQ, what it is, see what problem I'm trying to solve, what solution I propose, and some improvements to that possible solution. So what is RabbitMQ? It's a multi-protocol messaging server. It's open source under the Mozilla public license. It's polyglot in many senses, because now you can also write Elixir plugins for Rabbit, besides using clients in many languages. And everybody knows in the Erlang community that if you are not doing Elixir, you are not cool anymore. So then it's written in Erlang that, okay, here is kind of, yeah, whatever. But back in the days when we choose to start using RabbitMQ, this was a biggie, because all the stuff provided by the OTP framework is code that the RabbitMQ team doesn't need to write. So the less code, less bugs, basically. So when we started using Rabbit, and a company I was working in China like 4 or 5 years ago, this was one of the reasons that helped us. And also RabbitMQ, I don't know how many of you are using Erlang in your company, in your day-to-day job, but RabbitMQ, or for us, was CouchDB, are, I think, one of the best excuses to get Erlang into your company without your manager knowing. Don't tell this to anybody. But when we had CouchDB running in one machine, like in the crappiest server that we had, and there were like a dozen PHP servers sending logs to that machine, and the machine was like getting all the requests funneled into this machine. It never crashed. So for us, it was really easy to say, now we need to use RabbitMQ. I mean, we had to use queuing, but it was quite easy to push that to management. So that's the secret virus. It's multi-protocol, so you can choose the mustache style you want in Rabbit. This ANQP is the default protocol, but you can do MQTT and Stomp. MQTT is pushed by IBM, but it's an open protocol, and I think it's used by the Facebook iOS chat. And Stomp is like a text-based protocol that CERN is using Rabbit and many other technologies with Stomp. Like everything that ends in MQ is probably used somewhere at CERN. So yeah, you can read why you will want to use one or the other there. And recently we released this called community plugins. So Rabbit can be extended right in Erlang, of course, or Elixir. You can add your own plugins for a new database or a new routing mechanism or authentication mechanisms and stuff like that. But building them was quite not so easy, because if we tell that Rebar is the start of the history in the Erlang world, Rabbit is pre-history, because all the building system in Rabbit is make-based. So good luck with that if you're not from the Rabbit team. So now we provide built plugins for for the community. And I say polyglot, you can use it from Java. I hear everybody cheering there, Node.js, woo. And Erlang, of course. And there is PHP, Ruby, .NET, Haskell, and many others. And officially, the Rabbit team supports this client and the .NET one, Enterprise. And then we have Erlang, because we use the Erlang client everywhere inside RabbitMQ or the plugins. I know the guy that supports the PHP library. He's giving a talk today at the Erlang user conference. The Ruby library is maintained by another RabbitMQ colleague, and the Node.js library is created by a former RabbitMQ colleague. So they are pretty well maintained, for some definition of well and maintained. And there is even the prehistory and dinosaurs. We also have everything covered inside Rabbit. This is actually a guy from Hewlett-Packard. They're using RabbitMQ a lot, and they explain things how to do with Rabbit. And yeah. And the marketing slide, yeah, there is people using Rabbit, Instagram, Indeed.com, Telefonica, Mercado Libre, NHS, and so on. Mozilla as well. Every time your browser crashes, your Firefox, the logs go through Rabbit, so Rabbit's like the NSA component inside the Mozilla setup, basically. So, and yeah, the New York Times also is using Rabbit, and it's actually really cool because the main architect of this solution, which is running in 6 AWS zones in Oregon, Dublin, it seems every time you go to the New York Times, there is a Stomp, something like that, connections to Rabbit, and they have 500,000 users, and they kept this connection times. And even the guy mentioned on the mailing list that many systems were crashing and Rabbit was still running, so that was cool to hear. That, yeah, I won't mention the others, but there were others crashing around. And the good thing is they have a very no SPOF solution with Rabbit, and this guy is always explaining how to achieve that, particularly using the Shovel plugin, a different plugin from the one I will mention today, although it's quite related. But yeah, search for the New York Times, you will see a lot of scalability tips inside the RabbitMQ mailing list. Yeah, it runs on every platform. And just to show you how RabbitMQ works, I want to do a demo with the RabbitMQ simulator. So everybody gets on the same page. I hope you can see this. So the idea in RabbitMQ or in messaging is that you will have a producer of data that will try to send data to some consumer. To do that, you need an address, which in RabbitMQ is called the exchange. So you send messages to the exchange, but nothing happens. Everybody can see that? OK, perfect. Why? Because you need a queue. The messages, they need to actually be sent to some queue. You do it that way. And then finally, you can subscribe your consumer to the queue. If you have way too many messages, you can add more consumers, and they will be sent to the consumers. And Rabbit will implement some kind of round-robin algorithm. Of course, you can have more than one queue subscribed to the same exchange. And then you can have things like routing keys to route messages. So what's the goal of having the exchange? If you can, why don't you just send messages directly to the queue? That's a common question we have. So for example, I live in Switzerland. In the main station, when you go to buy tickets, there is like a computer there where you choose you want an international ticket or a local ticket, let's say. So if you press local, you will get a number, and that number will put you in some queue. At the end of the queue, there is the people at the counter, and you get to the counter. Those are the consumers, let's say. So here in the binding key, I can have international, and this one local. And whenever I send a message, if in the routing key I have local, it will only go to that queue. And if I have international, it will go to the international queue. That's because we have a direct exchange here. There are many types of exchanges, like fan out and topic. There are basically different kind of algorithms for doing the routing. the direct exchange is choosing the destinations, in this case the queues, in a kind of select from queues where routing key equals binding key, something like that. RabbitMQ uses niche inside, so there is no actual SQL query, but yeah, that's what the direct exchange is doing, matching routing key and binding key. The fan-out exchange just doesn't care about the routing key. So if you send a message, it will go to everybody, like in a pub/sub broadcast kind of thing. And then with the topic exchange, you can use routing keys with patterns. I'm not going to get there, but for example, you can say international Norway, and you can have a different queue for international Sweden. Is SK or SE? Good. So when you send the messages, if I do like that, it will go to that queue, but that's kind of the same as the direct exchange, but I can have another queue bound as international star, like an asterisk, or octotorf, like they call them in Austria, and it will go also there. So if tomorrow the Faroe Islands are also getting messages, they will go to the top one, as an example. So in the topic exchange, you can use patterns to choose where to send the messages. And because this is just a routing algorithm, you can add more routing algorithms into Rabbit. There is consistent hash exchange, modulo hash exchange, last value cache exchange. There is one I implemented called reverse topic exchange, which reverses the way this pattern matching works here. And there are many kinds of exchanges, and they are like, the amount of code you need to implement in Erlang is probably 10 lines of Erlang to get a new exchange into Rabbit. Does anybody have a question about how this works, the RabbitMQ messaging? 9? Good. That is good. Now we continue. So I'm learning like very advanced German in Switzerland, so I need to practice. So what's the problem I'm trying to solve here? Maybe you've seen this on the news, probably in The Guardian. There is applications around the world, and we want to send data there. You can make the connections you want on this kind of pattern. It's very recent in the internet. Some guys know them related. I think in Sweden this is not very welcome, but anyway. So we have data. We want to aggregate data here for some reason. And the idea is like, how will you implement that? Like, you have your application there before, and you're getting events, something is happening there. The same is here, there, and there, right? And you want to get this happening. How do you do it? Of course, you can, there are many possible solutions, and let's see what are the trade-offs and things like that. So let's say in this location here, this location, yeah, I need to improve my pronunciation. So how do you get data into RabbitMQ? In Erlang, for example, you will open a connection with some parameters, like here you can pass the user, password, and all the stuff, but let's use just default. And then in RabbitMQ or in AMQP, you will get a channel, because you can have only one TCP connections and then many channels. And in Erlang, this particularly makes sense because you can have all the parallelisms that process provide you. In PHP, this is like, cool story, bro, and good luck with that. I always get people asking me in the PHP library, why you cannot do this or that with PHP? Come on, let's move on. We are in 2014 already. Anyway, yeah, so you get the channel, and then you want to send messages somewhere. That somewhere is the exchange. We do exchange declare. some name like events, type, direct. And RabbitMQ or the library will choose like a sensible set of defaults in those records, so you don't need to provide all the options, but there are quite a few options in AMQP. So you have the exchange, and then you have you can publish the message using the channel. You always send commands in the channel using AMQP. So you'll do basic publish to the exchange, and then you create a message with some properties. Delivery mode 2 means that you want to have persistent messages. By default, they are not persistent, and some payload. So that will get the message into RabbitMQ. So that application that, let's say, was in Brazil or somewhere in Europe was just sending events into Rabbit using this code. So how do you consume messages from Rabbit? You will have, again, a connection and a channel that's exactly the same. Then you can declare the queue and bind into the exchange. So again, the exchange declare on top, queue declare here. And we do the binding from the queue. In this case, I didn't provide a name for the queue, so RabbitMQ will auto-generate a name, and it will be returned here. This record is the return value of queue declare OK. You have the queue name, and then you do the binding to the exchange events and that queue. You can, of course, provide a queue name if you want there. So we have the queue. And then we start consumer. Also on that queue, we tell Rabbit that we are not going to acknowledge messages. So as soon as they arrive the consumer, they are deleted from the queues. And the process that will get messages is self, like the caller process. We wait till we receive a basic consume OK. This means we are already subscribed to the queue. And then we loop. So in the loop, we receive messages, but particularly basic deliver, and we get the message, body, and we do something. I mean, that's some example code that is processing messages that are coming through RabbitMQ. Of course, as you know in Erlang, you want to prevent to catch all the messages, else your memory will blow up, all the patterns. We should know that, I guess. So this is example. So we get producer and consumer of data, but how do we actually do all this replication? We can start another process, as you can see, or you saw in the example in the simulator. You can have more than one queue listening on the same exchange, or getting data from the exchange. That means you can just start a different one, bind it to the exchange, get the messages, and try to replicate to the remote server. But there could be some issues. What happens if the remote server is offline? How do you prevent, in that case, unbounded local buffer? So your network connection to the state is broken. You still get a lot of messages, and this keeps growing and growing and growing. Your sysadmin went holidays in Hawaii, I don't know, or is at the Erlang user conference. So how do you get to get the connection back? And messages keep piling and piling and piling in Brazil, let's say. How do you prevent message loss? If the other end is offline, how do you know that the message that you just published to the remote server arrived there, didn't arrive there? What happened? How to prevent unnecessary message replication? It could be the case that there is no more need for these messages on the remote server. They're maybe too old. Perhaps there is no subscriber for that kind of messages anymore. So there are many problems that can cause like unnecessary traffic on the network or message loss and stuff like that. So is there a better way? Of course. You can use RabbitMQ. That's why I'm here with the salesman. I need my tie better. So using RabbitMQ, I mean, I shouldn't say this, but this is really an NSA pattern. You will see why. Please cut the film there. So RabbitMQ has a plugin called Federation that supports replication across different administrative domains. You can mix the Erlang and the RabbitMQ version of on the different clusters. support network partitions. Woo, we have the buzzword checked. And we don't need to federate everything, as I was explaining before. And you can achieve things like that. If any of this is a RabbitMQ server, you can do like this kind of fan out, let's say. And you can specify the max hops, like how much the message can jump. This is really Rabbit speech, the max hops of the messages. You can create like a ring if you want, and send the data around, put a limit of 5 in this case, so you won't keep looping that message around. And the Federation is just a plugin, and internally it's using queues and exchange decorators. So all the stuff you learned in the Java Enterprise Edition, blah, blah, we still have it in Rabbit in Erlang. So we never escape from that. And it's really easy to configure it using parameters and policies. You will see what's that soon. So basically, you enable the plugin. You enable management if you want to click around to configure that. We have like a wave UI where you can control RabbitMQ. And this is how to set a parameter. We are going to use the RabbitMQ CTL. This is command line stuff from Rabbit, setting a parameter called Federation Upstream. My upstream is the name I'm going to give it. And then I just specify an AMQP URI to connect to the remote server. And I'm telling how long to keep messages around in the local machine. And then I set a policy where it will apply to all 2 exchanges, and every exchange that starts with the name AMQ dot. Here you can have a regular expression saying events or whatever your exchange name is. And then the upstream set, we have many upstreams, but they all belong to the set called all. You can create your own sets of upstream servers. Think like in the river, you have the upstream, and the water flows downstream. So the upstream server is where the data comes from, and the downstream server is where the data will go to. So once we apply these 2 commands on the command line, a parameter and a policy, Rabbit will do something like this. This is what I call the NSA pattern. So this is a server where you have a set of queues and consumers getting data out of Rabbit, and somebody's publishing messages. Then there is another server somewhere else in the world. Somebody's sending messages there, and somebody is consuming messages. When you magically enable the Federation plugin, these things happens. So messages from here start to be shipped to this server. This publisher and those consumers have no clue that the messages came from the other server. And this publisher here also doesn't know that we are also federating messages. And what RabbitMQ will do, it will create this kind of ghost queue there in the background that will also pull messages. And depending on the configuration is how it will ship messages to the other server. It will try to wait for a confirmation from the remote server before it deletes the message from there, or it just sends the message. There are many options there. But basically, when you enable Federation, you will get this link between the brokers with some things that RabbitMQ or the Federation plugin will do automatically for you. So whenever you want to configure the Federation plugin, you need to have these parameter things where you get a JSON object. That can be something like that, like the URI of the remote server, prefetch count. You are telling the consumer that is shipping messages how many up to how many messages it can keep in memory before RabbitMQ keeps sending it more messages. Reconnect delay in seconds if the remote connections cuts, when to try again, and so on. And the acknowledgement mode on confirm means when the remote server confirms that it received the message, then this process will act to the local Rabbit that the message is consumed. So we have this queue here, also getting the messages going to this exchange. When this server confirms back, then we act the message here. In Rabbit, there is the concept of acknowledgement. If you have a consumer, the consumer can be in ACK mode or in no ACK mode. In ACK mode, every message, it has to be acknowledged back to Rabbit. So Rabbit knows this message is processed, we can delete it. But in no ACK mode, Rabbit just sends messages as fast as you can process them, basically. So if you want to prevent unbound buffers, you can use two options. One is expires, and one is message TTL. Expires is used mostly for queues. If the queues is not used for the n milliseconds, then Rabbit will just delete the queue. And message TTL just applies a TTL to messages. So that will tell this ghost queue basically how much or how long to keep messages, let's say. Because for us, maybe these kind of events are not worth anymore. Then max hops is to prevent the messages from keep cycling, let's say, and if we have a loop of federated brokers. Then we have the ACK mode. There is onConfirm, as I explained before. If the remote server confirms the receipt of the message, then the message is ACK in the local server. OnPublish means as long as I'm able to publish the message, then it will be ACKed in the local server. And the no ACK one is the living la vida loca version, where you get the messages. If they are processed, sent, not sent, Rabbit doesn't care anymore. So these are the options. And of course, the speed changes depending on which one. Faster, slower, safer, unsafer. That's the trade-off. So that's what an NQP URI is, how you create one. You can see all this doc here, what's the spec, but it's basically like user password, host port, and virtual host for, that's a RabbitMQ or NQP thing. Yeah, then the configuration of this plugin can be applied using RabbitMQ CTL, the HTTP API, or the management interface. And I don't know if you know, but the HTTP API is a REST interface that RabbitMQ provides, where you can create queues, you can create exchanges, do binding, delete stuff, purge queues, disconnect users, and a lot of things. And the management interface, which is like a web page, is built querying that HTTP API. So if you need to do some kind of ops thing, the Rabbit has this whole rich HTTP API where you can control the whole broker. And RabbitMQ CTL is just the command line thingy. So that's what we get with Federation. Basically, all the stuff that I was talking before is done automatically by the plugin, and it tries to do it smart in the sense that preventing unbound buffers, detecting if the remote connection is broken, stuff like that, so you don't lose data or lose as much as you want, depending on the options you choose, and so on. So we got all the distribution of data, but there can be some problems, specifically related to how RabbitMQ and Erlang interact together. But keep in mind that if you reach this point of what I'm going to explain, you're really maxing out, I mean, not maxing out Rabbit, but you have a high volume of messages. To be in the 40,000 messages per second is not that much for Rabbit. I would say from there to 100,000 is still what should be able to do, depending on your options and settings and whatnot. So if you have 1,000 messages per second or less, then I'm not sure this applies. But we have some clients where this applies. So one problem that Rabbit has is that the queue contents, they live in the node where the queue was declared. So in Rabbit, you can create a cluster, like a normal non-federated cluster, like an Erlang cluster of nodes. But in the node where you send the queue declare, that node will have the queue contents. Of course, you can set up mirroring. RabbitMQ has mirror queues that do replication of the queue contents, but still you will have a master queue. Okay. Then when you have a cluster, the queue can be accessed from every node in the cluster. And the other problem is that queues are Erlang processes, so they are tied to one core. So unless I mean, to max out the amount of cores you have, you probably, if you have only one queue for everything, that will underutilize the server. If you have more queues, then you don't have this problem. So what happens is if you reach the max of what one queue can give you in the computing-wise, let's say, if you add more nodes, this won't help at all because still that queue will have the contents in that machine, and there will have the bottleneck. So we try to create something called sharded queues, which is a new plugin that adds either a modulo hash exchange or a consistent hash exchange to do partitioning of messages, and then just plain old queues. The problem, as you will see, there are many pieces on this puzzle. That's what we try to solve with a plugin. You could implement this with RabbitMQ out of the box without the plugin, but you need to kind of modify a lot of things. So you will have a stream of messages, let's say into an exchange called images, and then you will have queues that they will get the messages in some order after the partitioning. So the trick is, because in an MQP, if you do qdeclare my queue in node A, and then you do qdeclare my queue in node B, and these nodes are clustered, you don't get a new queue, because that queue already exists in the cluster. That's why, for example, you can create a queue called images1, images2, images3, so they are actually different queues for RabbitMQ. And then with an exchange, which is either modulo hash or consistent hash, you can do the partitioning. So if you have node A and then the exchange, in this case a consistent hash exchange, the top queue will live in the node A, the second one will live in node B, and then in node C, and then you can do all this partitioning. And if you use this kind of name, like node name.queuename.index, so some node, the queue that I actually want, and then depending on the cores you have or some kind of metric, you have queue 1, 2, 3, 4, 5, whatever. You bind those queues to the consistent hash exchange or partitioner exchange, and then you get you need to tell the consumer to get messages. But having this setup is too complex for any app. You don't care about all the stuff, I guess. So we created the plugin that, besides setting this up all automatically, will do transparently for the consumer that you just need to send queue name. So if you tell Rabbit, I want a shard called events, and then you do consume from events, RabbitMQ automatically will know which of these queues to find for you. Because you are connected to a node name, the strategy is to pick a local queue, so you don't need to have inter-cluster traffic of messages. And the index of the queue will depend on the amount of consumers. The queue with the least consumers will get the consumer, the new consumer. So the sharded queue plugin will partition the messages. They will arrive at several queues, possibly in a different node in the cluster. But as a publisher, you don't care about that things working behind, and as a consumer, you also don't care. You just have a big queue which is kind of distributed in your nodes in the cluster. What happens if you need more scale? For some reason, this doesn't scale up to what you actually need. We have something also called federated queues. So the federated queues, they can load balance messages across the queues that you declare as federated only when you need to have that. So if you see how RabbitMQ works, you send messages to a queue. That's the final destination after you got routed from the exchange, or after you did or Rabbit did the partitioning, the message is at the queue. But that queue is getting filled up with messages and messages and messages, and your consumer cannot keep up. You add more consumers, still you cannot keep up with the amount of messages that come in that particular node, for example. The federated queue will pick messages from one queue and send them to a different queue, possibly in a different node in the cluster. So in that way, you can scale after the fact you partition or route the messages. So exchanges give you this kind of scalability before the fact the messages arrive. There you will send them to one place or the other. With the federated queues, it's after that you cannot do anything else with the message. Still, Rabbit can show move messages around depending on the load of each queue. And it's really simple to set up. You set the upstream like we did before, and then instead of applying the policy to exchanges, we apply them to queues. We provide some regular expression again, and the upstream set. Questions up to here? No? So with Rabbit, what we can do is like we can have data coming into Rabbit from different protocols, and it can be mix and match. So you can send data on MQTT or Stomp and consume an MQP and stuff like that. If you have federation, you can distribute this across the globe, and the idea specifically is to support like the distant networks, not specifically for I mean, you can use it in a local cluster, but the idea is that you will send stuff across availability zones in Amazon, for example. I don't know if anybody from the state here. Do you know ADP? ADP? Okay, so ADP, I think, processes all the payments in the state for salaries, right? So if ADP doesn't work, people get angry, probably. Yeah. So ADP uses Rabbit, and they use Federation for their setup. And because they wanted to have isolated clusters of RabbitMQ where each team works in that thing, and they don't touch the other people rabbits, let's say. This sounds like rabbit inbreed people something, community. And I will be, instead of the crazy lady cat crazy lady, I will be the crazy rabbit guy, something when I'm old with all my little rabbits. Anyway, so if they use Federation specifically for that, to accommodate this thing. So it's tested, it's used in production, it's not just my talk. With sharding, take it with a grain of salt. I'm trying to run some benchmarks on EC2. We are going to open source a solution to run benchmarks with RabbitMQ that you can describe the scenario you want to run in JSON, really simple, like I want 10 consumers, 5 publishers, persistent queues, persistent messages, blah, 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 blah. But just having this JSON, you can run the scenario. Or you can tell Rabbit first send 10 kilobyte messages, then 100 kilobyte messages, and then 1,000 kilobyte messages, and see how this varies over time with all the different benchmarks. So you can specify this in a JSON file, and the tool will be able to run this stuff and also produce the nice graph that you can show the management. So I'm trying to get this all ready to actually get the best out of this plugin to move it in a forward for people to use. Still, it's out there, it's ready to use, but you never know. Be my guest. And yeah, after we do the sharding, we can load balance using federated queues. So to get messages once they are in the queue, move to a different queue for scaling. Everything is about scalability. Wow. Credits, the world map is from Wikipedia. The diagram from Federation is from RabbitMQ. Questions?
First, thanks to Alvaro.
Thanks.
And now we take the questions.
Hi. How you would prevent to consume a message twice in a federation setup?
So the question is how to prevent to consume the message. So ideally, it's in the better world, Rabbit never sends a message duplicated. If your consumer acts the message. If for some reason your consumer got the message, let's say resized the image, then crashed and didn't manage to act the message, that message will be sent to a different consumer. So those are the cases where RabbitMQ send duplicated stuff. Or if you have a network partition, then the cluster doesn't know that in the other side of the cluster, people were hacking messages. So these are the, I would say, the two cases where that will happen. But by the spec of the protocol, Rabbit should not send messages twice. If you acknowledge the message, or if you are in no hack mode, the message will be removed automatically. As long as it's sent, it's gone from the queue.
Okay. So it's not related by the number of messages that RabbitMQ push in advance. I think I saw that RabbitMQ could push like 100 messages at a time, and that means that is not waiting on any hack. That means if he push 100 messages on one federation, he could push 100 messages on the other. Therefore, there will be both in memory on each of consumer. No.
I'm not sure I follow, but if you use Federation, you don't have consistency. Okay. Because there are two separate clusters receiving, like, the messages coming from the federated link, they are like a publisher sending messages. So the original broker has no clue if the other side consume or not the messages. Now, if you have a normal consumer connected to a local broker, you can set what is called the basic QoS, basic quality of service in Rabbit. You can tell Rabbit, I want to process 100 messages each time. Those 100 messages are exclusive of that consumer. So if that consumer crashes, those 100 messages go back to the queue. And if whenever the consumer acts one message or all the 100, you can do multiple act also for speed. Then those messages are not sent to a different consumer. But that's in this world of this broker. Yeah, but in the federated one, there is no way to
there is no way to have one message to be sure that the message is just consumed once. There is no simple way to do that. Between federation, I mean.
Between federation, no, because you have two separate worlds, let's say, that they keep their own states.
Okay, thank you.
So what the New York Times advice, they build all about idempotency, that to have the consumers be able to manage the duplicated messages.
Okay.
But they use Shovel instead of Federation, which can similar. But
okay, thank you.
Any more questions?
No?
I think they want to get you during coffee.
Probably. Thank you very much.
Thank you.